So the second page are slightly more complicated problems where we have a situation and then we have to figure out, is it linear, is it quadratic, is it exponential, and we have to build an equation. I start off kind of easy where I say, hey, which equation could it be? But then later we actually have to come up with the equation ourselves after we read the problem. So let's do a few of these. So we have a bunch of different ones here. I'm going to do 2 of these for now and we can do more later. Question number 1, a rental car company charges $30 plus 40 cents per each mile driven. Which of the following could be used to model the total cost of the rental where M represents the miles driven? I'm assuming the total cost should be in dollars, even though they talk about dollars and cents here. So I'm assuming that C is total cost in dollars. And we got to be careful mixing dollars and cents. So let's copy this into a new page. And I'm going to ignore what they wrote for a second and just see if I can figure it out on my own. Okay, so one thing that jumps out at me here is with the 40 cents, it's per mile. Per means divide. So that would be 40 cents divided by 1 mile. And fractions like that make me think of slope. Okay, so I'm thinking the 40 cents is the slope. Mixing cents and dollars is dangerous, so I think I would rather rewrite that as 40 cents like this, okay, per mile. And so the 30, regardless of whether I drive 1 mile, 2 miles, or no miles, they're going to charge me $30. So that's my starting point. All right, so starting at, which is the y-intercept. So thinking about the whole y equals mx plus b thing, when we have slopes, if I used y, I think it would be y equals 0.4. I don't really need that extra 0 there, times x plus 30. And they want me to use c for total cost, so I'll write c equals 0.4 and m for the mile, so m plus 30. So I think that would be my equation right there. Sometimes looking at all those different options on a multiple choice fries my brain. So a lot of times I ignore it for a minute and I write down my ideas, and then I look back to see if my idea is there. If it's not, I rethink my ideas. So looking back at the options I was given, 0.4 m, there's only one of those that has that, and I had to make cents into dollars, and then there's the plus 30. Yeah, so my idea was one of the given options, so I go with it. And again, right away, that 40 cents per mile made me think about slope because of the word per, and so I say this is linear. And then they want me to find the total cost of driving 400 miles. So I have to decide, am I plugging in an M or a C here? And they definitely say M is miles, so I'm just plugging in 400 miles. So back in my notes. Whoa, freak out on the pen. Cost of 400 miles means C equals 0.4 times 400 plus 30, and at this point it's calculator time. So 0.4 times 400 plus 30, $190. Seems reasonable. Again, I should also write this down in my notes. Again, C is cost, so that's going to be dollars. All right, questions on that one?
Nope.
Okay.
I think I'm good.
Thanks. All right, so let's submit, get some green checks. That looks nice. All right, let's see. We could either do Washington's GDP or coral reefs dying. All right, let's pick one of these. Somebody want to vote? The gross domestic product of Washington or coral reefs?
Can we do the number 8?
Number 8, gross domestic product. Yes. So GDP stands for gross domestic product. I believe this came up in a previous homework somewhere. But this is a new version of a problem. So let me see. We have the GDP in Washington is $577 billion. So that right there is an estimate of all the money that's made in Washington in 1 year. And I'm assuming it's this year. And there's a note here, I could look it up if I wanted to. And then there's a growth rate of 3.1%. All right, so once I see growth rate percent, I'm thinking this is an exponential function. So let's copy this down and see if we can write in a formula. Copy. And let's see, I'm just gonna grab this for now and we'll get the other information later. All right, so cues in this that catch my attention. Okay, so GDP of Washington is $577 billion. So we should read the whole thing before continuing with a growth rate that's catching my eye, and that's a percent. Write an equation that can be used to estimate the size of Washington's economy in a future year, assuming the same relative yearly growth rate. So I've mentioned the idea of relative growth rates before. We talked about relative rates versus relative change versus absolute change. Once we get into relative change, the formula looks something like y equals a times b to the x. And the b to the x comes from the 1 plus r that we talked about with compound interest. So now my formula is starting to look like this. Okay? And R right there is that relative growth rate. If I take and add 1 to that, so just note 3.1%, and that extra 0 on the end is not all that important, is the same thing as 0.031, because remember the percent symbol means to divide by 100. So if I take 3.1 divided by 100, I get 0.031. If you're unsure of that, whip out your calculator. So the most common mistake people make on this one is they mess up converting the percent to a decimal. So just remind yourself that percent means divide by 100. So if I take 3.1 and divide by 100, double check on your calculator is always a good idea. There's my 0.031 that I wrote down. So check, 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 always got to check. So when I calculate what is 1 plus r, it's going to be 1 plus 0.031, which those add up pretty nice to just 1.031. And once I get that 1 added to it here, this thing right here, that whole base is called the growth multiplier. So if the growth rate is about 3%, the growth multiplier will be about 1.03. Go the other way, if the growth multiplier is about 1.03, then the growth rate must have been just the 0.03. Okay, so that's my growth multiplier. And A here must be my starting point, that $577 billion. So now I got to figure out how to write an equation. So let's see, next they say let G be the state's GDP in billions of dollars. So instead of a Y, they want me to use a G, and it's in billions, so I don't have to add any zeros. So I'm just gonna write 577 times that 1.031, and then the power is just T years from now. So instead of an X, they want me to use a T. So this is my equation. And I used the exponential equation because they gave me this relative growth rate. They didn't give me a slope. They gave me a growth rate as a percentage. 99.99% of the time, that means it's exponential. Okay, then I have to use that in a scenario. So let's go see what the scenario is. Okay, I'm gonna put in the equation right away. G equals 577 times 1.031 raised to the power t. And if you accidentally type the wrong variable, you should get a warning. And so if it says, hey, syntax error, check your variables, right? Double check. On the side here under basic, it says, hey, you should be using G and T. Okay, so I say, oh, crap, T, not X. Okay. Not a huge deal, but I'll look for problems like that after you take the test, but still, you want to get it right on your own. And we decided this is exponential because we have a growth rate here. Okay, use the equation to determine Washington's GDP 6 years from now. Cool, they gave me T. That means that's easy. I just plug in and see what happens. You don't have to solve anything. So for the last part, G equals 577 times 1.031, and mine was to the 6th power, and so I can just type that into my calculator as I see it. And just double check that I have the right numbers there. 577, 3.1% growth rate for 6 years. 577, 3.1% growth rate for 6 years. Yep, that looks right to me. And do they give me round to the nearest billion? Okay. The nearest billion, that 9 here rounds that 2 up to a 3 for me. So I would say it's 693 billion. Let's write that down. That's about 693 billion. That's the number I want there. So read carefully. And I think I got it. Read all the fine print. They just want me to enter an integer or a decimal, but here to the nearest whole billion. Yeah. All right, so this next one is similar, but a little bit harder. And then we've done one like the car depreciation. So let's see, I want to do one more on this page. Does somebody want to see the coral reef or the car depreciation?
Which one's harder?
I think the coral reef is harder.
Okay, I think that one then.
Okay, but I could be wrong. Let me see. Okay, we'll just do them both. They're both hard. Let's do them in order then. All right, coral reef problem. So you would have gotten one similar. There might be a slight difference in your percent and in your initial value there. And similar to above, we want to know what the equation is. We want to know what family this is from. And then we have to try and figure out what this last question means. So let's just start off by analyzing the paragraph. Okay, so coral reefs throughout the world are dying at a rate of about 1.5% per year. Okay, so since I have percent per year, I'm kind of leaning toward exponential because there's a percent and they use the word rate. If they said like 1.5 square kilometers per year, then I'm thinking, nah, slope. But the percent and the rate are making me think exponential. Write an equation that can be used to determine the future area of coral reefs that now has an area of 300 square kilometers squared. Let C be the area of the coral reef in T years from now. Okay, so again, I'm leaning, because they use the word rate and there's a percent, I'm leaning toward exponential. So like before, I'm thinking, all right, exponential is y equals something like a times b to the x, but they're giving me a growth rate here. So the b is probably a 1 plus r to the x, and then we have our starting amount there. So similar to the last problem, I think that's the kind of equation this is, but they want me to use c instead of y and t instead of x. And then sometimes I get confused, like, well, which one is x? Is x the t or the c? So then you have to think about, like, what's the independent variable and what's the dependent? X is the independent variable. Independent. And y is dependent. And time depends on nothing, right? It just keeps going. We can't stop it. It just keeps clicking away. So generally, if there's something like years or months or minutes or hours, I'm thinking, yeah, that's probably x, the independent variable. So sometimes I have to think through that. Sometimes it's obvious. Okay, so I'm just going to look back at the question, see if there's any other clues that might confirm this, that it's an exponential, not a linear function or equation. So we had that paragraph, we looked at it. It's either quadratic, linear, or exponential. Nothing to indicate it's quadratic. Well, no, that's not true. I do have square kilometers. Uh-oh, that's a little confusing point there. Use the equation to determine how many years until the reef decays. Okay. So the only thing I have to go on is that I have a rate and it's a percent. I think it's exponential. Okay, so we're going with it. So I'm going to rewrite this then as C equals, starting at 300 times 1 plus, we have to change that 1.5% to a decimal. And 1.5%, remember, percent means divide by 100. And so I think that's going to be 0.015. Double check on the calculator just to be sure. Even if you think you're right beyond any doubt, double check. 1.5 divided by 100, 0.015, just like I thought. It's a good day. And then they want me to use t instead of an x, so I'm getting that in there right away.
Would that number be negative because it says that it's dying?
Oh, it's dying. Thank you. It's a negative. Good call. Whew. Yes. All right. Glad you're paying attention to the fine print. Yeah, we're going to subtract. That's a negative rate. So if we add a negative, it's subtracting. And then we should clean that up there. I'm definitely going to ask my calculator for help on that one. I don't want to mess it up. 1 minus 0.015 gives me 0.985 as my new base. So 985 thousandths. Oops. There we go. Okay, so there's my cleaned up formula that we're going to play with. All right. Enter that in, then try and solve the next part. I think C is 300, at least my version of it. Yours will be slightly different. Okay, and it didn't give me any warnings, right? If it does give you warnings, read it carefully and rethink what you wrote. I believe it is exponential because the power is variable. And now I just have to solve the next question. All right, and blow that up a little more. Okay, use the equation to determine how many years. Okay, so how many years? So in other words, what is t, right? Because t is supposed to be a question mark, is the number of years until the reef decays to 203 square kilometers. So 203 is definitely an area. That's my C. So they're saying C is 203. So just double check with yourself which variable you're given, the independent or the dependent. So in my equation right here, I'm going to plug in 203 for C. So we dropped from the 300. How many years until that happens? So we have to figure out what T is. So to solve an exponential equation, we did one of those earlier today. We are going to first get rid of the multiple, that 300. And this is essential. That is the best way to do this. 300 there, 300 there. My guess is dividing by 300 is going to be a bit messy. Let's check. 203 divided by 300. Yeah, that's a lot of weird decimals. It's only 6 and 7s, but it's messy. I'm going to stick with it as a fraction. And this Desmos would tell me if it reduced. It doesn't reduce. So I'm going to leave it. But on the right side, I can definitely clean things up a bit because 300 divided by 300 is 1. 1 times 0.985t is just 0.985t. Oops, missed digits. And on the other side, I'm just going to leave it as 203 over 300. If you wanted to write down all those decimal places, that's cool too. You'd probably be okay. But if just you rounded it to like 2 decimal places, you might get too much rounding error in your answer by rounding twice. Since I have the base to the power alone, I'm ready to use a logarithm. So I write log parentheses on each side. And then it's time for a new screen. So I've got the log of 203 over 300 equals that log of 0.985 to the power t, but logs have that special property that powers pop out. So I'm going to pull the t out front right now. So again, when we have the log of a power, the power pops out as a multiple. So now I just have t times this crazy number. The last step is to just divide by the crazy number, and that number is called log of 0.985. Nothing simplifies here without a calculator. So the next step is to just go to my calculator and ask the calculator, what is this whole thing right here? Because on the right side, I've got a number divided by itself, which is 1. 1 times t is t, so whatever that is my answer. So now we just carefully plug it in, and if you could play along and see if I get this right. New line in Desmos, log parentheses 203 over 300, close parentheses in the right spot, then divide by the log of 0.985. I think I typed that right. I'm getting a little over, almost 26 years when I calculated that. So again, this is a complicated one. It's good practice to try it on your calculator, see if you can get the same number as me. About 25.8-ish. What were the instructions? Round to the nearest year. So I would say that's about 26 years till the coral reef drops from 300 square kilometers to 203 square kilometers. Questions on solving that or the calculator result?
No, I think I got it.
Okay, cool. Thanks, Alan. So I would believe it's about 26 to the nearest year. Again, your numbers will be slightly different, but the process is the same. Whew, got it right. All right, one more on this page. Number 10, a new car was valued at $38,000 and depreciates to $13,000 over the next 4 years. Okay, so let's say I bought a car this year at $38,000. 4 years later, it's only worth $13,000. Use the exponential equation for depreciation to answer the following question. what was the annual rate of depreciation to 2 decimal places? Ooh, then I'm going to find R. Okay, let's do it. So I'm going to copy the first paragraph plus question A. And again, when you're doing your homework and taking the test, I hope you summarize the important details. That'll help your brain wrap around what the heck to do. So I needed a new page. All right. And you will have a similar version, slightly different numbers, probably. All right, so we're told to use the depreciation equation. And so that's kind of like what we just did. I'm going to write, let's say, y equals some starting amount times, since we're depreciating, we'll write 1 minus r, and then it's to the power t or x, whatever we want to call it. And they didn't say whether to use x's or y's or t's, so I'm just going to use y's and x's here. So this right here would be the depreciation equation. And R is the rate. Now they didn't give me the rate, but they did give me what the new car was valued at. So that's my A. They're giving me 4 years later, that would be an X. They're telling me down here to find R. So the $13, it depreciated to, this is just a future amount, which is a Y value. Okay, so I believe the 13,000 is the Y, some future value of the car. So plugging those things in, I get 13,000 equals A at 38,000. Make sure you get the right number of zeros, times 1 minus R to the power, and they're saying it's 4 years later. So I'm given everything except R. I need to now find R. So I have to solve for R. So this one is especially challenging because usually we're given the rate. This time we're not. And we have to figure out how to find it by solving this equation. So when we're solving equations, we do things that are furthest away first. So the furthest thing away from the R is the 38,000. It's connected by multiplication, right? So we would, to get rid of that multiplication, we divide. And again, the point of doing that is I have a number divided by itself connected by multiplication. Number divided by itself is 1. 1 times that stuff is just itself. So that side cleans up good. On the other side, I should probably whip out my calculator to clean this up, but I'm going to note that they have 3 zeros each, so I could divide top and bottom by 1,000. So it could simplify to 13 over 38, which isn't too bad as fractions go. Let's double check on a calculator. And again, even if I just want to go back to this, even if you're sure you're right about that it equals 13 over 38, on a test, double check on a calculator. So calculator, 13,000 divided by 38,000. Either it gives me this decimal that has a lot of different numbers in it, or I can say, hey, decimal is kind of a fraction, and it says 13 over 38. So I'm going to go with the 13 over 38. Alternatively, you could copy down maybe all of these decimal places to avoid much rounding error. Your choice. I happen to like fractions. Okay. Next, what do I do next? Well, the -1 here is close to R. The 4 is a little farther because it's outside the parentheses. So I want to get rid of a 4th power. Does anybody remember how to get rid of a 4th power from last week's stuff?
No, I don't remember.
Okay, so if that was a 2nd power, I would take a square root. So to get rid of a 4th power, we take a 4th root. So that looks like this. It looks like the square root symbol, but a little 4 gets dropped in there. And a lot of calculators have a button for that. So we'll see if my Desmos one does. I got to do the same thing on the other side. So I want the fourth root of that fraction. The point is the fourth root and the fourth power cancel, leaving just the 1 minus r on this side. So I'm going to check what this is on my calculator because I'm getting close to the end. So new line. And my calculator does have an n root button. And so on Desmos, I click it and then it says, okay, what's your root? I say I want the fourth root. And then inside the box, I click or use the arrows if you're on a phone. And then just type your 13 over 38 or the decimal version if you're using that one. Let me know if you have calculator questions about how to get that number.
I have a question. So I
Yes.
think in one of the later problems, you said that if your calculator doesn't have the number, like for example, like the 4 square root, then you would just like use the exponent of the opposite. So would it be like
you would use a fractional exponent? Yeah. So on a if I didn't have that button on my calculator, I would use the power 1/4. So it'd be 13 over 38 in parentheses, and then the power would be 1/4. So like I'll show that on my Google calculator. All right, so on Desmos, it came out to 0.76478-ish. And I should be able to do that here too, but I'm just going to use Google because it's a little cruder. Google, I was already at Google, I knew that. 2 + 2 brings up the calculator. So I would start with the parentheses. I got my 13 over 38 in the parentheses. And then I say I have a power. Come on, give me the power. There we go. And on this calculator, I need that power in parentheses because it's more than one thing. So I have 1 divided by 4 as the power. And I should get the same thing that Desmos gave me, the 0.76478. So again, it is important that we're comfortable using our calculators for a variety of different computations. Good question. All right, so I'm going to grab the first 3 decimals there. I would round the 4 to a 5 because of the 7 that comes next. So I'm going to call it 0.765 for now. And let me pull this out of the way. So that's just another way to write this thing right here. And I think it's about 0.765, is that what I said? Yep. For my version of it. And there's a couple ways to solve this from here. So 1 minus something gave me that number there. So what I'm missing is what do I need to get up to 1? So I can kind of just guess that, well, it's got to be whatever 1 minus that is. So this is kind of guessing at the answer there. So if I go back here, enter, and say, what is 1 minus that previous answer? And I don't think Google has a previous answer button, do they? Oh, they do. So I could say, what is 1 minus the previous answer? And Google says it's 0.235-ish. So I think the rate of depreciation is about 23.5% is what it looks like here. If I wanted to do this more algebraically than kind of guessing at it, then I actually have to solve this. So let's go through how to do that instead of guess. I would take this 1. It's positive, so to get rid of it, I have to subtract it, even though it's connected by subtraction. So I'm going to have to do a -1 like that, because 1 minus 1 is 0. 0 minus r is -r. And then on the other side, I get kind of the opposite of what I wrote there, 0.765 minus 1. So calculator time is, it's going to give me a -0.235. And to get rid of that negative by the r, there's two things you could do. You could either multiply or divide by -1. A negative really means multiply by -1, so I'm going to divide by -1, which makes that positive, giving me the number I guessed at over there. So I'm getting a rate of depreciation for this problem, for my numbers, of about 23.5, and they're saying percent. So pay attention to whether that percent symbol is there or not. So I had to convert the 0.235 by multiplying by 100% to get 23.5%. Next, I want to check to see if this actually works. So to check it, I'm going to use the information I started with up there. So let me copy that over. And the check here is important. On the homework, right, you just get to hit submit and it tells you whether you're right or wrong. The test, that doesn't happen. So you need to know ahead of time before you hit submit. So let me copy this to a new page. So what I'm going to do here is I'm going to use the initial part in the 4 years and see if I can use my new rate to get that 13,000 there, right? So I think my new equation is y equals 38,000 times 1 minus that rate as a decimal, 0.235, to the power t in general. And I want to plug in a 4 there. Now, 1 minus that 0.235, that's going to be that 0.765 here, my growth multiplier. So now I have y equals 38,000 times 0.765, and I'm going to put the 4 in there. So what I want to see is if I plug in the 4, do I really get about 13,000 like the problem started with? All right, question. So check in the calculator. Now, because this is rounded, it's not going to be exact, but I hope it's pretty close. So clear 38,000 times 0.765 raised to the power 4, and hopefully, yeah, that's pretty close to 13,000. I rounded to 1/10%, and so it's a few dollars off, but it's close to 13,000. So I think I'm right. All right, so I've got this, that's 23.5. Now they say, okay, well, what's going to happen when the car's 10 years old? Well, I have an equation now, right? I can just use it because I know what the growth rate is. So I can just next, oops, color, next, let t equal 10 for 10 years. And so on my calculator, I just simply ask what is 38,000 times that 0.765 that I cleaned up above is to the power 10. So that last part's pretty straightforward. The hard part was part A. But I might as well get credit for it while I'm here. Calculator, please. 38,000 times 0.765 raised to the power 10 is, it's only worth about $2,600, $2,600. Okay, so over 10 years, cars lose a lot of value, especially this car. And cars depreciate at different rates. Some cars hold their value better than others do. How do they want the answer? Round to the nearest dollar. I would have totally missed that if I didn't read back. So then I would say it's $2,609. Don't forget about the fine print. How should it be rounded, if at all? Oh, shit, what did I get wrong? The 23.5. Oh, it said round to 2 decimal places. See, that fine print got me. Darn you. All right, so I'm lucky I got that last one right. So back here to 2 decimal places, it would have been 7648. So 2 decimal places here, because we got to multiply by 100%, would be 2352. So I need one more place. Oops, read the fine print. Okay, so again, before you submit, double check you read all the fine print. I caught it in one place, but missed it in another.